Okay, good day, our dear learners. Before we start with the lesson proper, I would just like to apologize for the technical difficulty that we experienced a while back. So to start our discussion, we have the definition of current. So as you can see in the illustration, we have a low current and a high current. Low current involves minimal charges, while high current involves relatively more charges. Therefore, current, as according to the illustration, it is the steady flow of charges. Now, we also have here current in a given conducting wire made of a metal. We define current as the rate flow of charge across a plane. So we have two words that should be considered in this definition. First is the word charge. Okay, so we have the word charge. And second is the word rate. Therefore, current involves two quantities. First is the charge, and second is the rate or the time. So current is mathematically expressed as I is equal to Q over T, where I represents the current that is measured in A or amp or ampere. Q represents the charge that is measured in C or coulomb, and T represents the time that is measured in seconds. So always remember that ampere is often shortened to as AMP or amp and is abbreviated by the unit symbol capital letter A. A current of 1 ampere means that there is 1 coulomb of charge passing through a cross section of a wire every 1 second. I repeat, there is 1 coulomb of charge passing through a cross section of wire every 1 second. So let's proceed to the problems in order for us to really understand the calculation or computation of current. So first we have a 2 millimeters long cross section of wire is isolated and 20 coulombs of charge is determined to pass through it in 40 seconds. So first is to write the given. We have distance is equal to 2 millimeters. Okay. Charge is equal to 20 coulombs. And time is equal to 40 seconds. Since in the given equation, we do not have distance or distance is not essential, therefore just focus on the charge and the time. So write the formula. Okay, we have current is equal to Q over T. Substitute the given values. Q is 20 coulombs divided by 40 seconds. So 20 divided by 40, that is 1/2 or just right, 0.5. And then don't forget the unit for current, that is amperes. So the final answer is 0.5 ampere. Next example. A 1 millimeter long cross section of wire is isolated and 2 coulombs of charge is determined to pass through it in 0.5 seconds. So just like in the first example, always write the given. Okay. So we have 1 millimeter as your distance, and then your Q is 2 coulombs, and time given is 0.5 seconds. So formula to be used, that is I is equal to Q over T. So substitute, we have 2 coulombs divided by 0.5 seconds. So this is 4 amperes. Okay, let's check it through a calculator. So it's 2 divided by 0.5 and it's 4 amperes. So our final answer is 4 amperes. Now, from the given examples, we can conclude that current is directly proportional to charge passing through in a certain period of time. When we say directly proportional, when charge increases, current will also increase and vice versa. Next, what is resistance? Okay, if we have current, of course, we also have resistance, and resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega, and ohms are named after George Simon Ohm or Ohm. Okay. Next, we have here the relationship of resistance to current and resistance to temperature. So the higher the resistance, the lower the current flow. Okay, take note, the higher the resistance, the lower the current flow. Therefore, the relationship between the resistance and the current is inversely proportional, meaning if one increases, the other one will decrease. Okay, and in addition, resistance is directly proportional with temperature. I repeat, resistance is directly proportional with temperature, meaning if resistance increases, so with the temperature and vice versa. Now, there are two words that you might be confused with. First is the resistance and second is the resistivity. Now, what is the difference between the two? Okay, as I've said, resistance is the opposition to current flow, while resistivity is a measure of the resistance of a given size of a specific material to electric conduction. Therefore, in order for us to determine the value of resistance, we must know first the value of resistivity in order for us to know the relationship between the resistance and temperature. Okay, I repeat, in order for us to um, compute for the value of resistance, we need resistivity in order for us to determine the relationship between the resistance and the temperature. Okay, so resistivity is commonly presented by the Greek letter rho or small letter p, as you can see. It is mathematically expressed as R is equal to resistivity times length divided by area. Okay, resistance is measured in ohms. Resistivity is measured in ohm meter, and length is measured in meter, and area is measured in square meter. Okay, so in order for us to get the equation under the resistivity, we have this mother formula or this original formula under the resistance. Okay, now we have to derive the value or the equation of resistivity. So we have R is equal to resistivity times length over area. Just cross multiply. So we have R times A, that is RA, is equal to resistivity times length. Okay? And then since we are looking for the resistivity, divide both sides by length. So cancel length to length. Now we have resistivity is equal to RA over L. Okay, so this will serve as our equation for the problems presented. So first problem, we have compute the resistivity of the given material whose resistance is 2 ohms, area of cross-section and length are 25 squared centimeters and 15 centimeters respectively. So first, write the given. Okay, we have R is equal to 2 ohms. Your length is equal to 15 centimeter. And we have to convert this 15 centimeter into meters. Therefore, let's multiply it into 1 meter divided by 1 meter is equal to 100 centimeter. Okay. So cancel centimeter to centimeter. 15 divided by 100, that is 0.15. Yeah, that's 0.15 meters. Okay, next we have the area. Area is 25 squared centimeters. Okay, so since 100 centimeter is equal to 1 meter and the centimeter under area is squared, therefore we have 100 times 100. So 1 squared meter is equal to 100 times 100, that is 10,000 squared centimeter. So 25 divided by 10,000 squared centimeter, that is 0.0025 squared meter. So let's just check. 25 divided by 10,000. Yeah, it's 0.0025 or 2.5 times 10 raised to negative 3. Okay. Now let's write the formula to be used. We have resistivity is equal to RA divided by L. Substitute, your R is 2 ohms and the area is 0.0025 squared meter divided by the value of length, which is 0.15 meters. So compute using your calculator. We have 2 times 0.0025 divided by 0.15. Okay, so we have 0.03. Okay, meter. Don't forget to cancel your units. Meter to meter. Okay, so the final answer is 0.03 meter. Now, another example, the length and area of wire are given as 0.2 meters and 0.5 squared meter respectively. The resistance of that wire is 3 ohms. Calculate the resistivity. Okay, so just like in number one, in number one example, just substitute the given value to the equation. But then we have to complete our solution, so always write your given. 0.2, that is your length. 0.5 square meter is your area. And your R is 3 ohms. So write the formula. Its resistivity is equal to R times A over L. To substitute, R is 3 ohms times 0.5 squared meter divided by length, which is 0.2 meters. So it's 3 times 0.5 divided by 0.2. Okay, we have 7.5 ohm meter. Force, again, the units. Okay, so we have 7.5 ohm meter. Okay, so next we have the conductivity. Okay, conductivity is the reciprocal, okay, reciprocal or kabaliktaran. Okay, conductivity is the reciprocal of resistivity, and it too characterizes materials on the basis of how well electric current flows in them. So conductivity is mathematically expressed as sigma. This is sigma. Spelled out na lang natin. It's SIGMA is equal to 1 divided by the resistivity. Of course, resistivity is measured in ohm meter, and conductivity is measured in Siemens or S over M. Okay, Siemens over M or S over M. So, in order for us to understand, let us apply this equation into a given problem. So what is the conductivity of a wire of copper given the resistivity of 1.68 times 10 raised to negative 8 ohm meter? So first is, of course, given. We have resistivity is equal to 1.68 times 10 raised to negative 8 ohm meter. Okay. Your formula is sigma is equal to 1 over resistivity. This is 1 divided by 1.6 times 10 raised to negative 8 ohm meter. Okay. So we have 1 divided by 1.68 times 10 raised to negative 8. This will give us 50, or exact value, 595,238.0. Mm-hmm. Okay. 595,238.02. Of course, don't forget the unit S over M. So I repeat, the final answer is 59,523,809.52 cmn over meter. Okay. So in simple words, we can say that electrical conductivity is the ability of a substance to conduct electricity. Okay. Next. Now, in the previous discussion, we discussed the concept of electrical potential difference, which is the voltage. You did know that voltage is the pressure from an electric circuit's power source that pushes charged electrons through a conducting loop, enabling them to do work. Now, the voltage, the current, and the resistance somewhat comparable to our lives. Obstacles, being the resistance, impede our movement to achieve our goals. But someone like your family or your own determination will push you to reach whatever you want to pursue in life. Okay, I repeat, the obstacles, ampere, this is you, and volt or voltage is your family or your inspiration or determination in life. Okay? So the relationship between the voltage, current, and resistance was further studied by George Simon Ohm, a German physicist and mathematician. Ohm found that there is direct proportionality between the potential difference across a conductor and the resultant electric current. Okay, so this relationship is known as the Ohm's Law. So, what is Ohm's Law, by the way? Ohm's Law is a law in electricity. It is the strength of a direct current that is directly proportional to the potential difference and inversely proportional to the resistance of the current. Remember this? Directly proportional to the potential difference and inversely proportional to the resistance of the circuit. Ohm's principal discovery was that the amount of electric current through a metal conductor in a circuit is directly proportional to the voltage impressed across it for any given temperature. Ohm expressed his discovery in the form of a simple equation describing how voltage, current, and resistance interrelate. So we have the equation under the Ohm's law. It's V is equal to IR. V is your voltage measured in volts. I is your current measured in ampere. And resistance is, or R is your resistance measured in ohms. Now in this expression, voltage is equal to current multiplied by resistance. Using algebra techniques, we can manipulate this equation into two variations, solving for I and solving for R respectively. So we have for I, it's V over R, and if R is missing, just write the equation V over I. So I repeat, I is equal to V over R, and R is equal to V over I. Okay. We have here a circuit. In this circuit, there is only one source of voltage, which is the battery, and only one source of resistance to current. This makes it very easy to apply Ohm's law. So let's try it in the problem. In this first example, we will calculate the amount of resistance given the values of current and voltage. So, we have just changed this into V. Okay. So voltage is equal to 36 volts and current is equal to 4 amperes. Now solve for the value of resistance. So formula, okay. We have the original formula that is VIR, but since R is missing, divide both sides by I. Divide both sides by I. Okay, and then cancel current to current. Now we have R is equal to V over I. Okay, so substitute the given values. Your V is 36 volts. Divide it by 4 amperes. Okay, so 36 divided by 4, that is 9. Yeah, so it's 9 ohms. Oh. So it's 9 ohms. Oh, ito na lang. 9 ohms. So in this first example, the final answer is 9 ohms. Next problem. In the second example, we will calculate the amount of current given the values of resistance and voltage. Given V is equal to 12 volts and R is equal to 3 ohms. And we are looking for the value of I. I. Formula to be used. But before using the formula of I, we should learn how to derive the equations using the original formula. So our original formula is V is equal to IR. Okay, and then divide both sides by R this time. Cancel R. Now we have I is equal to V divided by R. So our V is 12 divided by your R, that is 3 ohms. So to make it sure, use your calculator. So 12 divided by 3, this is equal to 4 amperes. Okay, so for number 2, the final answer is 4 amperes. Next problem. In the last example, we will calculate the amount of voltage supplied by a battery given values of current and resistance. Okay, we have R is equal to 7 ohms. I is equal to 2 amperes. So V this time. No need to derive, of course. We have V is equal to IR, substitute the given values. V is equal to 2 amperes times 7 ohms. So 7 times 2 is equal to 14 volts. Okay. Therefore, the voltage is equal to 14 volts. Okay. Now, we're done discussing with current, resistance, conductivity, resistivity, and Ohm's law. Now, we're down to a type of force in Ohm's law, which is the electromotive force. Now, what is the difference of force into an electromotive force, and for what is the electromotive force? So the electromotive force is the total voltage induced by the source. In other words, it is the amount of energy supplied by the source to each coulomb of charge. It is measured in volts and presented by the symbol epsilon. So I repeat, electromotive force, it is the amount of energy that is measured in volts. Okay? Measured in volts and not in joule. Okay? It is a type of force, but then it is not measured in joule. So the EMF, or electromotive force, is the maximum voltage that can be attained by the circuit, as I have said a while back. Naturally, it is generated when the fluctuation occurs in the magnetic field. The EMF is expressed by the formula shown below. So we have E is equal to IR, or epsilon. You may use epsilon, is equal to IR. So electromotive force measured in volts, I of course is the current measured in ampere, and R is the resistance measured in ohms. Okay, let's proceed immediately to the given problem. A circuit which consists of a battery connected in series with 10 ohms resistor. The potential difference across the resistor is measured as 2.5 volts. So In order for us to determine the needed value, of course, we have to indicate the given. So we have R is equal to 10 ohms, and the potential difference, or the V, is equal to 2.5 voltage. And we are looking for the value of the electromotive force. But then, our formula in finding for the electromotive force is E is equal to IR. Okay, since we do not have yet the value of current, let us solve first the value of current using the values of R and V. Okay, so we have the Ohm's Law formula, which is V is equal to IR. Okay, and then divide both sides by R, divide both sides by R. Therefore, we have I is equal to V over R. So V is equal to 10 ohms divided by 2.5 volts. So 10 divided by 2.5, it is 4 rather. So it's 4 amperes. Okay, so the value of I is 4 amperes. Therefore, let's write here I is equal to 4 amperes times the resistor, or the resistance is 10 ohms. Is it, wait lang, 10 divided by, okay. So this must not be 4 amperes. Balik that. Let us erase this part. I'm so sorry. It should be this should be V. Okay, it's 2.5 volts divided by 10 ohms. So, baliktad tayo kanina. Baliktad ako kanina. 2.5 divided by 10 dapat. That is 0.25 and not 4. 0.25 amperes. Okay? Now, let's have here 0.25 amperes times R, 10 ohms. So 0.25 times, no, let me next. 0.25 times 10, that is 2. It's 2.5. And then the unit for electromotive force is, of course, volts. Therefore, the value of electromotive force in this example is 2.5 volts. Next, a rod of length 0.40 meter moves in a magnetic field of magnitude B is equal to 1.2 T. The EMF induced in the moving rod is found to be 2.40 volts. Find the current if the total resistance is 1.2 ohms. Okay. In the problem given, we have here the value of magnetic field, but magnetic field will be discussed soon. Okay, so for the meantime, just focus on the quantities that are involved in the equation, and just disregard the value of magnetic field and the value of length for the meantime. So we have here 2.40. This will be your E, or your electromotive force, 2.40 volts, and the resistance is 1.2 ohms. Okay, formula E is equal to IR. Now we are looking for the current, therefore divide both sides by R and then cancel R to R. We now have I is equal to E over R. So your E is 2.40 volts divided by 1.2 ohms. Okay, 2.40 is equal to 2.40 divided by 1.2. Okay, it's 2 amperes. Okay, so the value of current having a resistance of 1.2 amps and an electromotive force of 2.40 volts is equal to 2 amperes. Okay, so that's all for the week 4. We calculated for the current, resistance, resistivity, conductivity, Ohm's law, and electromotive force. I hope that this pre-recorded discussion would help you to understand our lesson and would help you to really motivate solving more problems. So just a short realization, like a current, we are really to endure the most painful and hardest things to continue living in this God-forsaken world. But always remember that we are not living to please anybody. Therefore, continue to flow, focus on your own path, and be determined to achieve your goals. Let your perspective be your own. Okay, so that's all. Good day and keep safe, everyone.